Building a KPI dashboard with Pandas. Welcome to this intermediate beginner lesson on building KPI dashboards in Python with Pandas. Key performance indicators are vital numbers that help organizations measure progress. In this lesson, we will build simple but powerful dashboard metrics using Pandas. We will use the famous Titanic dataset to explore, clean, analyze, and visualize data. Let's get started. Running the cell now. Let's warm up with a quick data setup and preview. We start by importing the warnings library and turning off all warnings. Import numpy as np. We set the random seed to 42 for reproducibility. This keeps our notebook output clean so we can focus on learning. Running the cell now. This initial code snippet sets the foundation by importing essential libraries and configuring the environment, with numpy's random seed ensuring reproducible results and warnings suppressed for clarity. Although there is no visible output here, these steps are crucial for consistent KPI calculations and clean dashboard visuals as we proceed. This setup ensures that all subsequent data manipulations and metrics in the lesson will be stable and easy to follow. Now that warnings are off, let's load our data. This comment indicates we are setting up the Titanic dataset for analysis. We import the Pandas library, which is used for data manipulation and analysis. We define the URL where the Titanic dataset CSV file is hosted online. We load the dataset from the URL into a Pandas data frame called df. We print the shape of the data frame to see the number of rows and columns. We print the first 3 rows of the data frame to preview the data. Running the cell now. The output confirms we have 891 records and 12 columns in the Titanic dataset, providing a manageable size for our KPI calculations. The preview shows key passenger attributes like survival status, class, age, and fare, which are essential for building meaningful dashboard metrics such as survival rates and class distribution. This initial inspection sets the foundation for extracting relevant KPIs efficiently. What other popular datasets do you know that are used for dashboards? What is a data frame? Pandas data frame is like a table of data with rows and columns. It holds our dataset, so we can select, filter, summarize, and plot with ease. Let's check out some basic info about our Titanic data. Running the cell now. Try exploring info, describe, and columns of df on your own after this cell. We start by previewing key information and columns in the data frame. This line prints the data frame's info, including data types, non-null counts, and memory usage. This line prints all the column names in the data frame. This line prints summary statistics for numeric columns, such as count, mean, and standard deviation. Running the cell now. This output gives us a clear overview of our Titanic data frame, showing it has 891 rows and 12 columns, with some columns like age and cabin air missing values. Notice the mix of data types, integers, floats, and objects, which tells us what kind of data each column holds. The summary statistics for numeric columns help us quickly understand distribution and central values, setting the stage for more detailed analysis. Get familiar with data frame info, it often helps you spot problems early. Data cleaning basics. Real-world data often has missing values or inconsistent formats. We want our KPIs to be based on clean data. First, let's find and handle missing values. Running the cell now. After this step, we will be more confident in our calculations. We begin by counting all missing values per column. This informs us where repairs are needed. Print the number of missing values for each column to see the data quality. We fill missing age values using the median. The median minimizes the impact of outliers. Replace missing age entries with the median age value to maintain data consistency. We drop any rows with missing embarked values, because there are very few and this column is categorical. Remove rows that have missing values in the embarked column to avoid issues with categorical data. Inform that data cleaning is done by printing a message. Print the count of missing values after cleaning to confirm missing data has been addressed. Running the cell now. Here we first identify that the age column has 177 missing values, and embarked has 2 missing entries, while cabin has many missing values. The code then fills missing age values with the median to retain data, and drops rows missing embarked since it's a key categorical variable. After cleaning, notice that age and embarked have no missing values, making our dataset more reliable for accurate KPI calculations. Notice how filling or dropping missing data ensures calculations are accurate. Convert data types for categorical columns to optimize memory usage. Convert the P-class column to category type since it has a limited set of classes. Convert that sex a column to category type because it contains a fixed set of values. Convert the embarked column to category type as it has a limited number of ports. Running the cell now. In this step, we converted key columns like P-class, sex, and embarked to categorical data types, which streamlines handling and analysis of these features. Although there's no visible output, this change is essential for efficient memory use and accurate operations on categories, preparing the data for cleaner, more reliable KPI calculations. Try converting other columns to categories if you spot repeated values. Creating KPI columns. KPIs should be clear and actionable. Let's create a few columns that we will use for our dashboard metrics. Running the cell now. Think about what KPIs matter most in your own work or projects. We add a column to flag if a person is a child, defined here as under 16 years old. This line creates the isChild column by checking if the age is less than 16. This line calculates family size by summing siblings as spouses, parents, children, and adding 1 to include the person themselves. Running the cell now. The code adds 2 key KPI columns, isChild flags passengers under 16, and family size sums immediate family members plus the passenger themselves. These new columns help us quickly segment data by age group and family presence, which are crucial for later analysis and visualization in the dashboard. Notice that these KPIs transform raw data into clear, actionable metrics. What other useful KPIs can you imagine for this dataset? This comment explains that we are filtering the dataset to focus on women, children, and third-class passengers. We filter the data frame to include only rows where the sex column is a female, creating a subset of women. We filter the data frame to include only rows where the isChild column is true, creating a subset of children. We filter the data frame to include only rows where the P-class column equals 3, creating a subset of third-class passengers. We print the number of women in the filtered subset by counting the rows. We print the number of children in the filtered subset by counting the rows. We print the number of third-class passengers in the filtered subset by counting the rows. Running the cell now. This output shows the counts of key passenger groups, women, children, and third-class travelers, extracted from the dataset using simple filters. Notice how each filtered subset's row count corresponds to a specific KPI that can inform our dashboard, helping us track important demographic segments clearly and efficiently. This step highlights the importance of creating actionable KPI columns by isolating meaningful groups in the data. Filtering is a big step toward flexible dashboards. Aggregating KPIs, survival rates. KPIs often summarize data, like calculating rates per group. Let's check the overall survival rate and break it down by class and sex. Running the cell now. Aggregate metrics make dashboards impactful and comparable. This comment explains that the following code calculates the overall survival rate. This line calculates the mean of the survived column, which gives the overall survival rate. This line prints the overall survival rate formatted as a percentage with 2 decimals. This comment indicates that the next section calculates survival rates grouped by passenger class. This line calculates the survival rate for each passenger class by grouping the data by P class. This line prints a title indicating that the survival rates by passenger class will be shown. This line prints the survival rates computed for each passenger class. This comment indicates that the next section calculates survival rates grouped by sex. This line calculates the survival rate for each sex by grouping the data by sex. This line prints a title indicating that the survival rates by sex will be shown. This line prints the survival rates computed for each sex. Running the cell now. The overall survival rate of about 38% shows that less than half the passengers survived. Breaking it down by class reveals higher survival rates in first class, around 63%, compared to third class, 24%, highlighting socio-economic disparities. By sex, females have a much higher survival rate, 74%, than males, 19%, emphasizing how survival chances varied significantly across different groups, exactly what our aggregation code aimed to uncover. Which group do you think had the highest survival rate? Advanced grouping, multidimensional KPIs. Pandas lets us group by several columns at once. This is helpful for KPI tables with multiple categories. Let's see survival rates by both class and sex. Running the cell now. Try grouping by combinations like embarked and P-class for new insights. Here we make a pivot table, which is like a dashboard KPI grid by class and sex. This appears as a table with classes on rows, sexes on columns, and rates filled in. Pivot tables make it fast to generate manager-friendly metrics without much code. Running the cell now. This pivot table shows survival rates by passenger class and sex, revealing clear trends. Females have significantly higher survival rates across all classes, especially in first and second class, while males have much lower survival rates that decrease as class lowers. Notice how grouping by both P-class and E-sex creates a multidimensional KPI matrix, making it easy to compare these key categories side by side. This demonstrates the power of multilevel grouping for detailed insights in complex datasets. Pivot tables are critical tools for business dashboards. Let us check the average fare for each boarding port and class. We group by both embark port and class, take mean fare, then unstack to make the result easier to read. This layout is useful when comparing key numbers side by side. Running the cell now. This table shows the average fare paid, grouped by both embark point and passenger class, with classes as columns for easy comparison. Notice how the highest fares are consistently paid in first class, P-class 1, especially for passengers boarding at sea. This demonstrates how multidimensional grouping helps us uncover nuanced patterns across multiple categories simultaneously. Visualizing these numbers helps reveal outliers quickly. Adding time-based KPIs. Dashboards often track metrics over time. Although Titanic does not have a proper timestamp, let's use the ticket column's first character as a proxy for time to create a demonstration. Running the cell now. How else could you make time-based KPIs with limited date info? If you are enjoying this, do not forget to like this video and subscribe to our channel for more lessons. Create a new column called FakeTime by extracting the first character from each ticket. Convert the ticket column to a string, then take its first character to form the FakeTime column. Add a comment explaining that the next step calculates the mean age grouped by a FakeTime. Calculate the average age for each group defined by a FakeTime to get a time-based KPI. Print the resulting average ages grouped by O FakeTime to observe the trend. Running the cell now. This output shows the average passenger age grouped by the first character of the ticket column, serving as a FakeTime proxy for time. Notice how the mean age varies across these groups, reflecting potential temporal or categorical differences in the dataset. This demonstrates how we can create time-based KPIs from imperfect data to track trends over time on dashboards. In real dashboards, real timestamps let you track changes daily, weekly, or monthly. This comment explains that we will visualize key performance indicators, KPIs, using plots. We import the matplotlib.pyplot module as PLT to create plots. We set the figure size of the plot to 7 inches wide by 5 inches tall. We create a bar plot showing the average survival rate grouped by passenger class, with specific colors for each bar. We add a title to the plot that describes what it shows, the survival rate by class. We label the y-axis to indicate it represents the survival rate. We set the limits of the y-axis from 0 to 1 to standardize the scale of survival rates. We display the plot on screen. Running the cell now. This bar chart shows the survival rate broken down by passenger class, P-class, revealing higher survival in first class and lower in third class. Notice how the distinct colors help differentiate classes, and the y-axis scale from 0 to 1 emphasizes the proportion of survivors. This visualization sets the foundation for adding time-based KPIs by demonstrating how to compare key metrics across categories. Try making your own chart for KPIs by sex or port. Introduce the Minute project to build a KPI summary dashboard. Create a new data frame named B_dashboard to hold key performance indicators. Define a column KPI with the names of the metrics to be displayed. Start defining the value a column with the corresponding metric values. Calculate the total number of passengers using the data frame shape. Sum the isChild column to count the number of children. Count the number of women by checking whether sex and column equals female. Calculate the average fare paid by all passengers. Calculate the overall survival rate as the mean of that survived a column. Close the dictionary and the data frame constructor. Print the resulting KPI dashboard to view the summary metrics. Running the cell now. This KPI summary shows key passenger metrics from the Titanic dataset: total count, number of children, women, average fare, and survival rate. Notice the total passengers, 889, matches the dataset size, and the survival rate, around 38%, highlights the outcome proportion. These baseline KPIs set the stage for tracking changes over time, which we'll proxy using ticket prefixes next. Add your favorite KPIs to this dashboard for more insights. This is a comment describing the challenge to add an interactive filter. We ask the user to type a port of embarkation to filter the data. We filter the data frame to keep only rows where embarked matches the user's choice. We print the number of passengers who boarded at the chosen port. We print the survival rate as a percentage of those passengers. Running the cell now. This output shows the count and survival rate for passengers who embarked at port S, based on your interactive filter choice. Notice how filtering by embarked narrows the dataset to 644 entries, allowing us to track key metrics like survival rate, 33.7%, specifically by embarkation port. This demonstrates how user-driven filters can customize time-based or categorical KPIs in a dashboard. Try ports C, Q, and S to see different results. A comment explaining that dashboards should handle missing data without crashing. We define a function to calculate survival rate safely from a data frame. If the data frame is empty, return none to avoid errors. If not empty, return the mean of that survived column. Prompt the user to input a port code, even if it doesn't exist. Filter the data frame for rows where embarked matches the user input. Print the number of filtered rows and the safe survival rate for that subset. Running the cell now. Here, the code demonstrates how to handle missing or empty data gracefully when filtering by a user input port code. Since the entered port doesn't exist in the dataset, the filtered data is empty, resulting in 0 rows and a survival rate of none, highlighting the importance of safe calculations in dashboard KPIs. This ensures the dashboard remains robust even when users query invalid or missing time proxies. What errors have you seen in dashboards before? How would you fix them? Recap what we learned. Loaded and explored Titanic data. Cleaned and converted columns for analysis. Created custom KPIs. Grouped and summarized key business metrics. Built and visualized a KPI dashboard. Added interactivity and handled missing data safely. Try building a similar dashboard with your own data or datasets from public sources. Practicing with new data is how you will master these techniques. Running the cell now. Which topic in this lesson was your favorite? Let us know in the comments below. Enjoyed this lesson? If you found this useful, please like the video and subscribe to our channel. Comment with your KPI dashboard ideas or questions. We love hearing from you. Happy coding and see you soon. Running the cell now.